we have covered all types of, majorly all types of study design. So very briefly, we will look back to learn how to look forward. There are few important things which we will cover. What is risk? What do you feel? What is risk? Risk? Any idea? What is risk? What do you feel? What is risk?
The chance of getting a particular outcome.
Chance. Very good. Or can we say it is a probability? Huh? How you are saying it is a probability? Probability, how we are calculating probability? कैसे निकालते हैं? How to calculate probability? Happening, non-happening, है ना? So if I say that there is a pregnancy and pregnancy outcome, we are interested in a, say, female child birth. So what probability we will be getting? 50-50, है ना? If I say, if I am throwing a dice, what is the probability of getting 6? 1/6, है ना? If I say that I have 5 notes, one is of 2000, one is of 100, one is of say 500, 10, 20, and I said that whatever note you are going to choose, it will be yours. कौन सा नोट चूज करेंगे आप लोग? 2000 का नोट चूज करेंगे, है ना? तो हमें तो चपत लग जाएगी ना, 2000 रुपये खर्च हो जाएंगे. So what I did, I am making all the notes of equal magnitude 10 rupees, and now I say that which note you will choose? Anyone. And what would be the probability? 1/5. So what I have done? I have made the event equally likely. Then you are calculating. If I say that what is the probability that this fan will fall down, and let me tell you, it is not 0. But you cannot calculate it using the formula which you are using at your back of the mind, that is favorable divided by total. Okay. So, but using classical we cannot do it, but using historical example, using Bayesian inference, we can give that value. It will be very close to 0. It will not be 0, but very close to 0. So we are able to calculate probability when there are certain axioms which is satisfied, and one such axiom is equally likely. Okay. Similarly, in the study design, it is very, very important that we should, whatever the risk we are measuring the likelihood of that risk with respect to the disease outcome. Okay. So risk is basically, you are very right, it's a type of a probability. Okay. So we would be measuring the risk in exposed group and risk in unexposed group. Okay. So probability, as we calculated, it is nothing but it is favorable number of event divided by total number of event. So if we are having a exposed group, so we would be favorable would be diseased in exposed group divided by total number of individuals in exposed group. Similarly, we would be calculating for the non-exposed risk in exposed, risk in probability in non-exposed group of your diseased divided by total individuals who are in the non-exposed group. And that ratio, when we are calculating, we are calling it as relative risk. So if we are solely calculating the risk in the individual groups, we are not comparing it, then we are terming it as an absolute risk. Absolute risk is not very important, not very useful. So unless and until we compare it with the group where exposure is present. Okay. So risk, as I have told, it is number of cases of diseased divided by number of people. So risk in exposed and risk in unexposed. This ratio is called your relative risk, RR. Risk in exposed and risk in unexposed. Okay. Now tell me, if risk in exposed is same as that of risk in unexposed, what will happen? इक्वल प्रोबेबिलिटी। इसका मतलब कि जिसको हम बोल रहे हैं कि ये रिस्क है, वो रिस्क नहीं है। रिस्क ऑफ डिजीज्ड in exposed is same as that of risk in your unexposed group. So whatever attribute you are considering that it is a risk factor, in actuality it is not a risk factor. Risk in exposed is high compared to non-exposed. RR जब दोनों बराबर रहेगा, we would be getting RR equal to 1. When risk in exposed is high, numerator is greater than your denominator, then what will happen? RR you will be getting greater than 1. Greater than 1 is, it means that whatever the value above 1 you would be getting, that is the additional risk because of the exposure. Okay. Now, whether that additional percentage of risk which has increased is statistically significant or not, that is a different question. Okay. But that extra percentage is the extra amount of risk which is added. Okay. So let's have a formula for relative risk. We have the risk exposed, non-exposed, we have the disease status, disease present, yes, disease, no disease. So risk in exposed, how much it will be? A upon A plus B, very right. Risk in exposed will be diseased, risk in exposed, कितने लोग इसमें diseased हैं? एक A और कुल कितने लोग हैं? A plus B. What will be the risk in non-exposed? C upon C plus D. Very right. So we have the formula for the relative risk. We are denoting it by lambda. It is A upon A plus B for the exposed one and C upon C plus D for the non-exposed one. ठीक है. So this finally we are getting. Okay. Now this, as you see, absolute risk is a type of a probability. Or probability we can, one multiplied by percentage, it is proportion, है ना? अगर हम बोलते हैं 20% chance है and we multiply it by 100, then we say that 20% overall we are getting 0.2, probability we are getting 0.2 and we are converting it into percentage to 20% out of 100. तो proportion है एक तरीके का कि 20% लोगों का है. So as we have seen in the last class that proportion, mean, all these things are point estimate. To have a better estimation, what we do, we have the interval, confidence interval हम लोग निकालते थे. How we were finding out the confidence interval? Anyone remember? कैसे निकाल रहे थे कल हम लोग confidence interval? Standard error, very right. Standard error was a important component which we were, what we were doing? We were adding it. Okay. So we were adding the deviation on the positive side as well as the negative side. And one important thing more we were doing in that formula. We were having point estimate plus minus standard error, star हमने बनाया था कल. If you remember, we have made a star, that was confidence interval. कितना interval आपको कितने किस confidence का चाहिए? 90%, 99.5%, what confidence you want? Okay, so proportion, for your mean we have seen the standard error was SD by root over n. Similarly for proportion also we would be having a different formula which is under root of PQ by n. But it is not important the formulas, the concept of standard error you very well know it. है ना? Standard error, lower the standard error you are getting, that means your sample is more representative for the population. Okay, your quantity of interest can be mean, can be proportion, can be correlation, anything. Okay, lower value, that means you are very close to your population. So similarly here, it's a type of a proportion. So if we are having a risk in exposed group. For this, we have to calculate the confidence interval. We can have this formula. Standard error is, here it is written R. R is, it's a type of a proportion only. We can take it as P, PQ upon N under root. And for finding out the confidence interval, we are having that point estimate P or R plus minus standard error, the same old formula which we have used. For this ratio, what happens when we are considering this ratio, what happens is that it becomes little bit positively skewed. For them, we are having this value for relative risk, we are having this value for the standard error, and we are using this formula, we are calculating the confidence interval. Okay. So, positive sign upper limit and negative signs in the lower limit. Okay. So, if you have to calculate the confidence interval for absolute risk, we will go with this formula. Whereas, if you have to calculate the confidence interval for the relative risk, in that case, you have to go with this formula. Here, the standard error is calculated using this formula. Point estimate plus minus. Here, we have taken the log values. Why we are taking the log values? As I have told that when you are considering the ratio, the distribution becomes positively skewed. We have seen certain distributions yesterday. Okay. So, it becomes positively skewed. So, in your data set also, if you find that in your, when you are collecting any data, if you find lot of heterogeneity in your data, very variation is there, what we do? We take log transformation, so that the variation get reduced to a certain region only. Okay. So, that this is nothing but this is a way of treating the data such that the skewness can be reduced to certain extent. So, what we are doing in relative risk, we are taking the log value of the lambda, log lambda plus minus standard error this formula, and then we are converting it. Okay. So, these things your computer will do, okay, but you should know the concept. Okay. I am not going into the mathematical detail how it is calculated, but you should know why we have used log here, okay, and relative risk why we have not used. Okay. This is an example, smoking and cardiovascular death. Okay. And suppose it's a follow-up study. Follow-up study means that it is a prospective one, that means it is a cohort study. Okay. And we have to calculate the relative risk. So, can you calculate the risk among smoker? What will be the risk among smoker? 31 divided by 1417, very right. And in the risk in non-exposure? 15 divided by 1898. And when we are taking the ratio of these two, we are getting the relative risk. Okay. So, and we can calculate the 95% confidence interval for risk among smokers, and we can calculate the relative, here we are calculating the risk for smoker, and here we are calculating the relative risk. Okay. So, here the log formula we are using, and here we are using the simple formula R plus minus your estimate. Okay. Okay. So, you can take the snapshot of this table and take a snapshot of this formula also, and you can calculate the confidence interval also, and you can recheck what values we are getting. Okay. Can it be done? हो जाएगा? ठीक है, आगे चलें. Now, the second one, relative risk, you know it. Now, another important tool in analytical study design is odds ratio. What is odd? Can anyone tell me what is odd? odds से क्या समझ रहे हैं? One different form. Okay. Anything else?
Chance of something happening.
Chance of something happening, not happening, very right. So odd is a type of a negative word, na? Okay. So odds is, as she has told it's very correctly, it's nothing but its probability of happening divided by probability of not happening. Okay. So we will directly come on the formula of odds ratio. Here, what is the probability of happening of this diseased? Yes, tell me. Probability of happening of disease in exposed group? A upon A plus B. Very right. And probability of non happening? B upon A plus B. So it will become, if we are calculating the odds, what will probability of happening? That is A upon A plus B, and probability of non happening, that is B upon A plus B. A plus B and A plus B will cancel out. It will become A by B. Similarly, the odds, a probability of disease in non-exposed case, how much it will be? C upon C plus D. And your non-disease, it will be D upon C plus D. ठीक है. So odds ratio, it's a ratio. तो रेशियो में दो चीज़ें आएंगी हैं. There is a difference between ratio and your rate and proportion ना. Ratio में numerator is a part of a denominator or not? नहीं. तो यहाँ अलग अलग है ना. We are taking the odds in exposed and odds in non-exposed. That's why we are calling it as a ratio, because numerator is not a part of a denominator. So odds in exposed, that is A by B, and your odds in non-exposed, that is C by D. And when we are converting it, you are getting the formula AD by BC. ये formula है ना odds ratio का. It's AD by BC. So I recommend you that you should not go with this formula AD by BC, because if ABCD are changed, your everything will be changed. Okay. Go with the concept, that is odds ratio is nothing but odds of happening of disease in exposed divided by odds of happening of disease in non-exposed. Okay. So I hope both the formulas for relative risk and odds ratio is clear. Similarly, for odds ratio, to calculate the 95% confidence interval, the standard error, we are using this formula, and to calculate 95% confidence interval, point estimate plus minus your standard error. Okay. So you can calculate the relative risk and its confidence interval, and you can calculate the odds ratio and its 95% confidence interval. Okay. So manually we are not calculating it, we rely on the softwares, but manually also you can use this formula and you can calculate it. It's not very difficult. ठीक है सबको? Okay. Now, a very important question: relative risk or odds ratio, which you consider is a better one? Can we calculate both in every type of study design? Where we can calculate your relative risk? Cohort ना? Why? जैसे कि हम लोगों ने बोला रिस्क है ना, तो रिस्क इन एक्सपोज्ड, तो risk in exposed, we are talking about the new cases. Okay. So the new cases we will only know when we are observing it, when we are doing a follow up. Okay. And odds ratio, odds ratio can be calculated in your cohort study design? We prefer case control. कोहार्ट में कर सकते हैं तो कर सकते हैं ना. कौन सा ज़्यादा अच्छा है? जैसे कि हम बोल रहे हैं कोहार्ट स्टडी डिज़ाइन स्टडी हायरार्की में देख रहे हैं अच्छा है, तो हम सपोज वी आर डूइंग अ कोहार्ट स्टडी डिज़ाइन. सो वेदर यू विल बी more inclined towards relative risk or you will be more inclined towards odds ratio? Relative risk. Why so? What fault odds ratio has done that you are not going towards them? It? I am biased? Bias कम हो जाएगा किसमें? अच्छा, can there be any situation when we can use both? Either we can calculate relative risk or odds ratio, more or less we will be getting the same result. Can there be any situation like that? Yes, someone is saying something. Let's see a situation when we can use both. And you people are right that ideally, if given a chance, we should go with RR. When the disease is rare in nature, if you remember the formula of relative risk, it was A into C plus D divided by C into A plus B. When the disease is rare in nature, what will happen? A plus B will be more or less equal to B. Disease is rare in nature. The magnitude of this would be A and C would be very, very less. So what will happen? A plus B can be approximated by B and C plus D can be approximated by D. So what is happening? Instead of C plus D, we are writing D, and A plus B, we are writing B. And this is your odds ratio. So you can see that odds ratio and relative risk are becoming more or less same. So you can estimate RR from OR when your disease is rare in nature. Okay. Then in that case, it is a better approximation. Ideally, your RR is little bit better estimated compared to OR. When both the values are very close to 1, then you can go with RR or you can go with your RR. RR or OR will be giving you more or less same type of outcome. But when you are getting the RR value slightly high, okay, your odds ratio will always be more, say I would be saying that it is more notorious compared to your OR. OR is more notorious compared to your RR. So if you are getting 1.5 RR for the same data set, if you are calculating OR, you will be getting a value higher than 1.5. If you are getting your risk, you are getting it as a protective one, less than 1, say you are getting 0.03. And if you are calculating OR, you will even get more smaller value. Okay. We will see one example. So given a chance, if you are going with a cohort study design, go with a RR. Okay. This is a data set. For this data set, try to calculate the RR and try to calculate the OR and tell me what values you are getting. OR निकल जाएगा A into D, B into C, AD by BC से, and we will be calculating the risk 9 divided by 18.5 and 1 divided by 982. We will be getting some values and we will taking the ratio of these two. It's a incidence study, that is, it's a cohort study design. Hmm? 4.9. Okay. 491. RR का वैल्यू है या OR का वैल्यू है? RR का वैल्यू है 4.91. $409 RR value. 491. And OR value? 981. You can look that RR value we are getting 491 and OR value 900 something. So you can look that it is almost double. Okay. And if this value is RR value is coming close to 1, OR value will be also very close to that only. Okay. So given a chance that of calculating option that you are having a cohort study design, we should go with a RR. Okay. But if the disease is rare in nature, then we can go with either. It's a good advantage in case control study design also. If you are getting a value very close to 1 for your OR, you can make a statement that the RR value will also be more or less close to that value only. Now, let us look forward. That was our relative risk and odds ratio, which was already covered. I have just given a little brush up on that. Now, coming on the concept which we would be dealing, confounding and interaction. Confounding. So, confounding or interactions are also called your third factor. Okay. So, confounders are those variables which are not of our interest, but which directly or indirectly alter the outcome. Okay. So, confounder are those variables which are not of your interest, but which directly or indirectly will alter your outcome. Okay. And we will come on the interaction also. So, here is an example. Here it is, we are studying a relationship between number of children and prevalence of your breast cancer from a sample of mothers, may be explained by age. So, here we are having age as a factor. Older mothers tend to have more children and also have a greater chance of being contracted breast cancer. Age is then a third factor that explains the observed relationship between childbearing and breast cancer. Okay. So, we are studying the relationship between childbearing and breast cancer, but age is a factor which is also having an influence on breast cancer. So, age is not the variable of our interest. Our variable of interest is childbearing, number of children she has given birth, and the disease outcome is breast cancer. We have not considered age, we are not considering age, but age is an important factor which may result in which may alter your outcome. Okay. So, we have to take care of that. Interaction, if instead the third factor modifies the relationship between risk factor and disease, then interaction is present. Let us look at an example, so to understand it, the difference between confounder and interaction. Confounder is clear to everyone. Confounders are those variables which will alter our outcome. Now, let us look at this example. In this example, we are studying the relationship between salt consumption and stroke in gender, male and female. The women with relatively high salt intake have moderately elevated risk of stroke compared to other women. So in females, what is happening? The females who are taking high salt are moderate risk of stroke, whereas men with high salt intake have substantially greater risk than do other men. So what is happening? Here the risk is moderate in females, but here the risk is very high in male. Okay. So ideally what should happen? Males and females both are same. Okay. There should not be any difference with respect to the gender, but the risk factor, which is the salt here, it is interacting with the gender. It is having somehow females are protected and males are getting more risk. So if the risk factor is such that it is varying with the risk level, it's varying with the levels of exposure, then we say that there is interaction effect. And let me tell you, it is little bit easy to control the confounding effect, but it is little bit difficult to control the interaction effect. Okay. So sex would then be the third factor that modifies the relation between salt and stroke. Sex would be said to interact with salt consumption in determining the risk of stroke. Okay. So the concept of confounding and interaction, is it clear to everyone? Confounders में क्या है? अगर confounding effect होगा तो male और female में एक जैसा behavior होगा. It will not be different. But interactive effect है तो it is having different magnitude of risk for males and females. I want to control for confounding and interaction, but I cannot. Okay. Often many people come to have a study design, and what they are saying is that we have these are variable of my interest, this is independent variable, and I am studying on diabetes, that is our outcome, or hypertension, this is my outcome, and we have done a study design. And then they say that I want to control for the interaction and confounding variables. Okay. But in their questionnaire, they have not collected the information on confounding or your interaction variable. That is the third variable. So whenever you design a questionnaire, you should always consider that variable which is not of your interest, but which directly or indirectly may alter your result. If you have not collected that information, suppose in that breast cancer example, okay, you have collected, tell me what is your number of children you are having, whether you are having breast cancer, yes or no, but you have not collected age, what was her age. So you cannot take care of that confounding effect age, because you have not collected that information in your questionnaire. So remember, whenever you are designing a study design, you should take care of that variable also, which is the third variable, which is not of your interest, but which directly or indirectly may alter your result. Okay. So we will see two hypothetical examples to illustrate the situation of confounding. Okay. So we have taken a data from European data set where generally the disease is considered, one disease is there and they are measuring it in a European world where generally low socioeconomic individuals are living in a rented house, and generally individuals who are of high SES strata are from the are having their own house. Sorry. Okay, sorry. So we are considering one example here. So situation 1, look at this. So we are having the risk factor. Risk factor is what? Having his own house or rented house. Okay. So here exposed means he is residing in the rented house. Not exposed means he or she is having her own house. And disease, say we are considering a disease, say cardiovascular disease we are considering. Disease yes, no. Okay. So risk in exposed 81 divided by 110. We are getting 0.73. Not exposed 28 divided by 210. We are getting 0.133. Total number of subjects which we are studying is 320. So we are getting a relative risk 0.73 divided by 0.13. So we are getting a relative risk of 5.52. So from this table, what inference we are drawing? We can draw very high risk. Na? We are having a very, very high risk. Okay. Now, what we are doing is that the individuals, someone is studying all the subjects, 320. Okay. And they are considering that generally this cardiovascular diseases, for that we believe that we have lifestyle is an important risk factor. We are considering, say, suppose a risk factor smoking. In our questionnaire there is a variable smoker. Smoking yes or no. Okay. And then we feel that there might be this, because of the confounding, because of smoking we might get this higher risk. So we want to control that thing. Okay. So again what we do, we stratified this 320. Out of 320, we try to find out how many smokers are there and how many non-smokers are there. So let's see that out of them we got 210 who were non-smokers. 110 individuals where smoking was present. Total we are 320. So 320 we divided it into smokers and non-smokers. We stratified this first table only, and then we are finding out the risk. So when confounder was absent, that is among non-smokers, so we would be having the risk will be 1 divided by 9.1, 20 divided by your 200, that is 1 divided by 10, total column is not here. Okay. So 1 divided by 9 plus 1, 10, that is 0.1, and 20 divided by 200, 0.1, and we are getting an RR of 1. Similarly there also we are getting a RR of 1. Okay. So what is happening? From where this 5.52 is coming? अभी तो रिस्क नहीं दिख रहा है ना, पहले तो रिस्क दिख रहा था. तो जो दिखता है वही होता है या जरूरी नहीं है. Same table, I have done nothing. I have just created a group. कि this is smokers and this is non-smoker, and we have done an analysis, and now we can see that there is no risk. So from where we are getting this 5.52? Very, very high risk, na? If you test statistically also, it will be coming p-value very highly significant. So what we can do is that to understand from where this is coming, yes, very right. We should look at the confounder. So let's look at the confounder. Let's make this type of contingency table: exposed, non-exposed, diseased, non-diseased for the confounder. So look closely the confounder. Confounder present, yes. Confounder absent, yes है confounder यहाँ पे, confounder absent है यहाँ पे. Diseased, तो confounder में disease कितना था? यहाँ देखिए, sorry, confounder में disease कितना? 80 plus 8 है ना, 88, and non-disease 22, and non-confounder में disease कितना है? 20 plus 1, 21, और non-disease कितना है? 180, 189. So we have again made this same table. So confounder present, yes. Disease is 88. For non-confounder, the diseased one is 21. Okay. And you can look, the total is 320 only, And for this confounder, when we are calculating the risk, 88 divided by 110, 0.8, and confounder absent, 21 divided by 210, and we are getting an RR of 8. ठीक है, तो ये जो रिस्क दिखाई दे रहा है, ये सारा का सारा किसकी वजह से था? ये सारा का सारा confounder की वजह से था. So it is not that the individuals who are living in a rented house is not a risk factor. It was the smoking who was the risk factor. Generally, it was more prevalent in low socioeconomic strata group, and they are generally living in a rented house. Okay, so it was not the house who was the culprit, it was the smokers, okay, who are residing in that house, because of which we were getting this values. Okay, is it clear? Confounding effect. Okay, so that's what we have calculated. RR, number of cases of disease divided by number of people at risk. So we are getting the value. So study design, analytical study design is not very simple. To establish real association, it is very, very difficult. Okay, Frahingham study, it's very, very popular. It took lot of time to establish that yes, there is an association. He had done a lot of study, multi-centric study. उसके बाद सिगरेट के पैकेट पे ये छप के आया कि दिस इज स्मोकिंग कॉजेज लंग कैंसर. अल्कोहल की बोतल पे अभी भी लिख के नहीं आता है. बहुत सारे लोग बोलते हैं कि इसके कारण ये चीज़ बढ़ रही है, लीवर डिजीजेज इंक्रीज हो रही हैं, बट स्टिल we were not able to establish the actual true relationship. Okay. Second example. In this example, you can see ideal that type of situation only there. Here we are having 1210 subjects, and we have calculated the risk, and we are getting RR equal to 1. RR equal to 1 means we can say that there is no risk. Okay. Later on, we find that there is an important third factor which we should consider. So this same subject 1210, based on that stratification variable, we have divided 600 when confounder was absent and 610 when confounder was present, and we have redone the analysis, and look, now we are getting a RR of 2.45. Okay. Again, look at the confounder. So when we are again doing it with respect to the confounding effect, we are getting a value of 2.11. So what is happening here? Here, both the confounding effect is somewhat cancelling out the real effect, okay, because of which we are getting no impact, 1. Okay. But in actuality, there is an impact, 2.45. Okay. So it is very, very important whenever you plan a study design and you are doing a cohort or you are doing a case control study design, to say that you are getting a higher risk, this much is a higher risk, before commenting this type of statement, you should be very, very conscious that whether you have taken care of the confounder or interaction or not. Okay. If you have not taken care of that things, you cannot make a statement that we are getting a significant association. It's a very strong word if you say that we have got a significant association, and the risk factor, for that we have not got, your relationship was truly not significant. So unless and until you test for confounding and interaction, you cannot say these types of statements. So for the confounder, you can do it. Again, we can remodify this table. Disease present will be 105 plus 195, that is 300, and absent is your 310, and we are finding here it is 2.11. RR we calculate, we are getting 2.11. Exposure to the risk factor and C are effectively cancelling each other impact. 2.11, 2.45, more or less they are of same magnitude, and we are getting a value of 1. When we will say that there is a perfect confounding? कब बोलेंगे कि perfect confounding है? Anyone? Here what is happening? Here, what inference you will draw? There is no risk. Okay, no risk. But actuality there is risk, significant risk. So what is happening? Your inference is changed. Okay, so perfect confounding means that in actuality there was an effect, but because of the confounder, your inference, you are not observing any impact, or reverse one. Okay, there was no impact, but because of the confounder you are getting a significant impact. Okay, so but ideally perfect confounding situation is little rare. Okay, I have made a data set like that so that it is visible, but somewhat you will be getting, always you will be getting some confounding and interaction effect, but perfect confounding is somewhat little rare in nature. So what we will get some impact of confounders. So how to identify the confounder? One, based on the statement I have told that it is that variable which is not of your interest, but which directly or indirectly is altering the outcome. But there are certain characteristics, important characteristics of the variable. If that variable is satisfying that characteristics, then only you should consider that variable as a confounder variable. Otherwise, you should not consider that variable as a confounder variable. If C is to be considered as a confounder, it must be related to the disease, but not the consequence of the disease. Very important line. Be related to the risk factor, but not the consequence of the risk factor. So you should not consider any variable which is a consequence of disease or a consequence of your risk factor. Let's look some example. Here we are denoting C as confounding, D as disease, and F as risk factor. Let's look at this example. Age is related to the stroke, age is related to gray hairs, but age is not related to gray hair is not related to stroke. Okay, so you cannot consider it as a confounding variable. Age is related to breast cancer, somewhat is related to the number of childbearing, but these are not directly related. Okay, similarly for the third one. Here, C not acting as a confounder. So here you can see that high cholesterol is related to CSD, smoking is related to CSD, but C is not acting as a confounder variable. Okay, in that example, you can see that smoking is causing fibrinogen. That means this is the consequence of this risk factor, and because of this fibrinogen, you are getting CSD. Okay, so fibrinogen cannot be considered as a risk factor because it is a consequence of this risk factor. Okay, so these are very important consideration while you design your study design, who to take as a confounder, who to take as a interaction variable. So these are the conditions. So what makes something a confounder depends upon the database observed relationship and a prior knowledge. Below are some summaries necessary conditions to decide which variables are potential confounder. If C is related to disease, that is the variable is related to disease directly or indirectly, and C is related to your risk factor directly or somewhat indirectly, in that case you can consider that variable as a confounding variable. But if C is a consequence of the disease and C is a consequence of the risk factor, in that case your C cannot be considered as a confounding variable. Is it clear? Confounding variable? नहीं जिसको समझ में आया कैन रेज द हैंड. ठीक है, तो वन जब हम स्टडी डिज़ाइन करेंगे अपनी केस कंट्रोल, तो ऐसे वेरिएबल को हम कंफाउंडिंग वेरिएबल नहीं लेंगे जो कि उस डिजीज का कंसिक्वेंस हो या उस रिस्क फैक्टर का कंसिक्वेंस हो, ठीक है। ओके, so far we have dealt with 2x2 design when we are having just smokers, non-smokers, only 2 factors. If there are more than 2 factors, okay, so for example, if you are having considering exercise and there we are having not someone is doing a good workout, someone is doing a average workout and someone is not doing at all a workout. Here we are having 3 categories. So if you are having more than 3 categories, we have a formula given by your Mental and Hengel's. Using that formula, you can directly calculate the odds ratio. Okay, so this is the formula. Using this formula, you can directly calculate the adjusted odds ratio, stratified one. Okay. Now, how to find out the? Can anyone tell how to find the about the degree of confounding? How to find how much was the confounding effect? कंफाउंडर का कितना इम्पैक्ट था, ये कैसे पता चलेगा? यस मैडम, हाँ, वेरी राइट। एक बार हम बिना कंफाउंडर को कंसिडर करके एक बार निकाल लेंगे ऑड्स रेशियो कितना आ रहा है, और एक बार निकाल लेंगे एडजस्ट करके ऑड्स रेशियो कितना आ रहा है, और दोनों का रेशियो ले लेंगे, तो जो भी डिफरेंस आएगा दैट वुड बी कंट्रीब्यूटेड बिकॉज ऑफ द कंफाउंडर. सो वंस वी विल कैलकुलेट द क्रूड odds ratio, and second time we will be calculating the adjusted one, this one. So we can calculate odds ratio crude divided by odds ratio adjusted. Okay, so confounders, I hope confounding is clear, everyone can take care of the confounding. ठीक है, तो अभी जब क्वेश्चन आर डिजाइन करेंगे तो वेरिएबल्स थर्ड वेरिएबल भी कंसिडर करेंगे विच यू फील आर मोर इम्पॉर्टेंट इन योर स्टडी डिजाइंस. ओके, एनी क्वेश्चन? ओके, इज इट क्लियर? बहुत बोरिंग हो गया क्या? ओके, वी हैव अ वेरी स्मॉल वन मोर प्रेजेंटेशन. अच्छा, थोड़ा सा इसमें इंटरेक्शन भी है. इंटरेक्शन थोड़ा सा देख लेते हैं. इंटरेक्शन जैसे कि हम लोगों ने बोला कि इंटरेक्शन कितने टाइप्स का है, ये सब देखेंगे. इंटरेक्शन का डेफिनेशन आप लोगों ने देख लिया है. व्हेन द रिस्क फैक्टर इज बिहेविंग डिफरेंटली among the groups, then we are saying that there is an interactive effect. Okay, so now coming on the types of interaction, how many types of interactions are there? Okay, first one, there is no interaction. So no interaction कहने का मतलब ये नहीं है कि जो there is no risk. Okay, no interaction अगर हम कह रहे हैं, lack of interactions means that comparative chance is constant. You can look at, you are getting a upward parallel lines, figure A, no interaction. Okay, so with respect to exposure and non-exposure, you are getting a parallel line. Okay, so with time there is no variation in the risk, overall it is constant. Okay, if you are getting simply no elevation, in that case you will say that there is no risk. Chance of disease यहाँ पे क्या बढ़ रहा है, exposure में high है compared to non-exposed. This is B1, dotted line is non-exposed and your straight line is exposed. So in exposed, we are having continuous high risk compared to non-exposed, and this is, we are getting over a period, the risk is remaining constant, angle is not getting changed. But in rest of the figures, you can see that angle is getting changed for exposure one. Okay, तो पहला वाला है, A वाला है, which we are calling it as no interaction. जो लास्ट वाला है, which we call it as antagonism. Antagonism figure D. This is the strongest type of interaction because it represents a reversal of effect. Antagonism is when the effect of risk factor A in the opposite direction when acting in the presence of exposure to the direction in which it acts in the absence of exposure to risk B. जहाँ पे हम लोगों को 1 दिखाई दे रहा था, वहाँ पे क्या हो रहा था? Both the effects were cancelling out each other. Okay. So figure C, synergism. Synergism is when the effect of A is in the same direction but stronger in the presence of B. Look at the figure C. यहाँ पे जब अनएक्सपोज्ड है दोनों एक जैसा है, लेकिन जब एक्सपोजर हो गया है तो इन प्रेजेंस ऑफ एक्सपोजर रिस्क हैज सडनली इंक्रीज्ड अ लॉट. यूनिलैटरलिज्म इज व्हेन A has no effect in the absence of B but is considered considerable effect when B is present. Okay, so in this interaction basically the first one is more important. Why? Because it is cancelling out the effect. Okay. Okay. So we are done with this confounding and interaction. To take care of interaction in statistics, we have a statistical tool which we calling it as a mental and Cochrane and mental Hengel test. To find we are using that to find out the effect of interaction, whether it is significant or not. Okay, if interaction effect, if this test suggests that your interaction, your null hypothesis is not rejected, then we can go for a confounding effect. तो जब भी हमको थर्ड फैक्टर चेक करते हैं हम, तो पहले हम इंटरैक्शन के लिए चेक करते हैं. अगर इंटरैक्शन का इफेक्ट नहीं आ रहा है तब हम कंफाउंडिंग के लिए चेक करेंगे. अगर पहले में ही इंटरैक्शन का ही इफेक्ट आने लगेगा, then we would be taking care of the interaction only.